talk slightly. So it's going to be navigating through the minefield of read across frameworks and tools from research to practical tools. For some of you, it might be a bit repetitive because I haven't got any really new results that I can share at this stage. So for those of you that have heard things, now's the time to fall asleep for the next 25 minutes. For those of you that haven't, I hope I can entertain you for that time to share some work that we've been doing. This is really work. We're in collaboration with Imran Shah, Chris, actually, I've got him in the acknowledgements, George Hellman, who's our student services contractor, and Pradeep, who unfortunately can't be here today, but we've been kind of working collectively in this area. I have a little disclaimer because from EPA you always have to have one, but I'll let you read that for yourself. I'm staring at someone from EPA that's telling me so. Anyhow, okay, I have an outline. I always like to have outlines just to sort of give you a perspective of what I want to share in the course of this presentation. So for those of you less familiar with read across, some of you might be really familiar. I wanted to just go through a few bits and background concepts and definitions just to put you on the same page. And when I say sort of navigating the minefield, I really think read across is a bit of a minefield in terms of there are so many different guidances and things in terms of how you go about constructing a read across justification and frameworks for how you go about evaluating and assessing them. And I kind of want to walk you through a few of these just to sort of put some context around that. You know, if you're entering this field for the first time, you might be a little overwhelmed, but hopefully I can hold your hand a little bit in terms of where we are with that and give you some type of perspective to help navigate through that. Then I want to switch gears a little bit and talk about some of the tools that are out there that can help facilitate read across and put them in the context of that framework or that workflow, a more generic workflow in terms of how you might go about doing read across. And then really hone in on one aspect, and that aspect is sort of looking at the uncertainty in read across predictions and what work we've specifically been doing in terms of trying to address and resolve those. And as all good things in EPA, we try and make these things available. So we've been doing a lot of work over the last few months in terms of trying to implement some of these ideas into a tool. It's on our development server at the moment, so I'm afraid I can't disseminate it out into the wider public community just yet, but I want to show you a few screenshots in terms of what it's looking like to give you some interest, a flavor, and perhaps generate some demand of, yeah, we want to see this a little sooner out in the public domain than just on our development server. So that's really what I mean by research and implementation. And then just to wrap up, just a few summary remarks. Okay, with me so far. Okay. So background and definition. So there's, I think, many different ways in which one can sort of describe read across and what it means. But I'm going to define it in this way, and this is consistent with what available guidance is out there. So it really is, read across is a data gap filling technique that's used within an analog or a category approach, which by virtue requires some more definitions. So what is an analog approach? And that really is a grouping based on a very limited number of chemicals. We tend to define our chemical of interest as a target chemical, and the analogues for the similar chemicals to that target as being our source analog. So that's kind of what we mean by an analog approach. And in concert then, a category approach is really we just got more chemicals in that grouping. So rather than just being one target and one source, we might have many source analogues for that one target. So just to put some perspective. So you have a way in which we can fill gaps for a target chemical by virtue of grouping them together with similar chemicals and being able to fill those gaps. So that's in essence what read across is. To show it graphically in a way, I have a specific definition for read across, which I've already kind of articulated, but we have a source chemical, we use the information for that to fill in a gap for a target chemical that is lacking that same information. And I make point here in terms of, you know, we talk about these similar chemicals, what do we mean by similarity? And I just want to sort of say that that is such a relative concept, it's not an absolute one, so similar with respect to something, and that usually is your your endpoint of interest or a specific study or so on. So all of this is basic stuff to get you on board. Where can you find more information in terms of, are there sources of technical and regulatory guidance that sort of helps provide a bit more flesh to what these terms and approaches might be? And there's actually quite a lot of information out there, and that's why it ends up being a bit of a minefield in terms of getting through it all. So there's original sort of guidance that was developed was under the EPA HPV Challenge Program. The same guidance got sort of propagated into the OECD Manual for Assessment of Chemicals. There was one specific chapter that really focused on how you could go about grouping chemicals and fed in some ideas about how you could use QSARs in that context. And we used that as a foundation to help develop the REACH guidance. And that sort of started off around 2005 or so. We worked together in partnership with OECD and developed a grouping guidance that sort of served both purposes. Would it be useful for REACH? Would it be useful for within the international community? And that was sort of published in 2007 and the REACH guidance in 2008. Well, in the meantime, an awful lot of experience in using read-across approaches, some good, some bad. And that experience and those insights and those difficulties we tried to sort of capture in an updated OECD guidance document in 2014, and some of the inputs to that was this ESITOC category document that formed part of some of the ideas to input. And in the meantime, MECA's sort of thrown out a number of practical guides. So there's an awful lot of this regulatory technical guidance, if you like. At the same time, there's lots of people in the scientific community that have been working on that. I'm being one of them. So there's work by P&G developing a framework. There's work by colleagues in NCEA that have been developing a tiered surrogate approach. I've done work. There's been work under CAT in terms of trying to sort of bring together some of the good practice principles. A lot out there in terms of, this is kind of a right field in terms of what can we do in terms of developing better read-across approaches. So there's an awful lot there. And that makes it kind of challenging. So if I deliberately had some of my slides in red because I wanted to hone in on a few of those. So for example, I don't know how well you can see that in the back, and I do apologize. It's just a screenshot of the actual workflow that you go through that is described in both the OECD and the ECHA guidance document. So you have a starting point in terms of, what are the steps you need to go through? And there's a level of iteration in terms of how you go about developing your category or analog approach and to what extent you might have to go back and revise it depending on how you've developed your data matrix and what trends you're seeing and so on and so forth. There's a similar sort of workflow in the P&G model by Sunday Wu. So again, it's a very small graphic and I'm not encouraging to read this from the slide, but just in terms of a workflow of what your search strategy might be for identifying analogs, your source analogs, how you go about evaluating them, how you construct your data matrix, and so on and so forth. And there's a questionnaire almost to help you guide through that type of process. I'm not going to say anything about the Wang et al. Approach because the authors are sitting over there and they know far more about it, but I wanted to sort of just acknowledge that there is an approach in EPA that follows some of the same principles, and in many respects is very much aligned with the existing regulatory guidance that's been published elsewhere. So the work that I had been involved in years past was really sort of looking at, was culminated into this ESITOC report, and really, although we didn't publish this workflow as such, in essence, what we describe really sort of fits this type of workflow, and it's more of a generic way of describing and synthesizing some aspects that's already in that OECD guidance or these other frameworks I've already made reference to. And we had some additional structure in terms of sort of defining each of those steps in more detail. And I'm going to hone in on this one. Purely out of bias, but because it's a little easier to read and it makes a lot of easy for you to understand in terms of this this workflow and how one can start to interpret some of the tools and some of the approaches that are out there that can facilitate read across. So in essence, we have this workflow. I call it category workflow. It can equally be an analog workflow. But it's just, each of these other frameworks is largely quite the same, and this is just a very generalized conceptual framework for it. So you start off thinking about what your problem definition is. What is my decision context? What question am I trying to answer? And that will dictate to a large extent how much effort, how much resource, how much confidence do you need in the output that you generate. Your next step in terms of thinking about that, what do I already know about my chemical to begin with? I've got my target chemical of interest. What do I know about it in terms of its toxicity? What gaps actually do I need to fill? And that will define your strategy for how you go about identifying analogues, how you go about evaluating their validity and their relevance, and then how you go about doing your data gap filling. And whether that is purely by read across, or whether you want to use a QSAR to fill a gap, or whether you want to develop a QSAR from the category members that you've included in order to make that prediction. This is an iteration, but I've included one final step that I don't think is as well captured perhaps explicitly in the other frameworks, which is this consideration of assessing your uncertainty. It's well recognized that there's going to be some uncertainty with the prediction that you make, but we ought to be more transparent about and quantify it to the extent that we can in order to help evolve. Is that okay for the decision that you're trying to make? And I think that aspect is sometimes lost. Now, if we think about that workflow, I want to switch gears a little and talk about some of the tools. And the difficulty there I found from talking to many people is, hey, there's this tool and there's another one and someone else has published something, and I don't have a sense of where should I use what tool and what aspect of read across does it help me address. And we've made some naive attempts perhaps, or some preliminary attempts in terms of trying to answer that question. So I've highlighted here just a few of the publicly available read across tools. I put read across in inverted commas in a way. These are tools that are really sort of targeted towards helping address read across. There's AIM, the Analogue identification methodology within EPA. There's a tool that we developed at the JRC years back called ToxMatch that aims to help do read across. There's the AMBIT tool by CEPIC LRI in Europe, the European Chemical Industry Trade Organization. There's the OECD toolbox that I'm sure many of you are quite familiar with. There's work at Denis Fourcher and Alex Stropcher's lab in the past that developed the CBRA tool, and I'll talk a little bit about that in due course. There's ToxRead that Emilio Benfinati at the Institute of Mare Negro has developed. And all of these tools, to an extent, address different steps of this workflow. And I've tried to annotate that purely by crossing, does it do something on analog identification? Yes, it does. How they go about doing it might be very different between the tools, but at least you have a sense of navigating that landscape to say, yeah, this tool only addresses this step, or this tool does a damn good job of these 3 steps, but maybe it doesn't do anything at the end. And I think that's kind of quite important to bear in mind, depending on what your decision context is and how you wish to use that tool and what you need to do. So I had 2 screenshots, and I know I'm always going to run out of time. So if you're not familiar with the OECD toolbox, this is just a screenshot to show, hey, it does some aspects in terms of identifying those analogs and helping you through the process of evaluating them and making a prediction. The ToxMatch tool has a completely different interface, but in a sense, when you work through that tool, there's many aspects that are covered in that workflow. So it does do some analog identification. It does do some evaluation, albeit in a very different way than the OECD toolbox, but there is a process, and you can clearly sort of see, yeah, it maps onto the overall workflow. I haven't gone through all the other tools. If you want to read more about this aspect, then our group did write a short review paper that tried to outline each of these different tools, these publicly available tools, and what our experiences were in using them in terms of providing some resource, if you like, of, you know, here's what they're based on, here's what they do, here's where we think they fit in terms of that workflow, just to give you some perspective. Now, if there are all these read-across frameworks for developing your read-across prediction, equally I said that there's frameworks to help assess them. And, you know, maybe this is an artificial loop because no one just does one or the other, but I think these kind of more tuned towards helping you assess your read-across. And by that I mean they're trying to address that step, the uncertainty step, really by trying to identify, document, and address to an extent those uncertainties that are associated with these read-across inferences or predictions. And I've just highlighted a few examples. Again, more work by P&G, work that we did under the Cefic umbrella, work done under the Cosmetics Europe umbrella, as well as what ECHA have published under their RAF, or their read-across assessment framework. So there's some examples. I'm not going to focus in on those because I want to talk about what we've done. So going back to my workflow, I'm honing in on this step, this uncertainty assessment. And many of you have heard me talk before. I kind of drone on about this because we all say that we want to, you know, how do we resolve it? What do we mean by uncertainty? What steps can we do to address it? And here are some examples of what might be sources of uncertainty. And all of these are pretty familiar and again, captured in many of those previous papers. We're all sort of saying the same thing. You know, number of analogues, how complete is our data matrix? What's our data quality for the underlying analogues for all those target and source chemicals? If you've got crappy data, well, chances are your read-across predictions aren't going to be so good either. Are you being able to see that data matrix to see what the consistency across your source analogues might be? You know, if you're seeing differences, you know, maybe you have an outlier. Maybe your data point for one of those analogues wasn't so good. But that starts to give you a measure of, you know, where might some of the problems be with your data set or with your read-across prediction. Other issues, you know, we talk a lot about similarity. We don't necessarily talk much about the dissimilarity, but subtle changes in your structure can lead to very differences in the toxicity outcome. You know, maybe that's a trigger for, you know, there's another reason for that. It could be metabolism. We have a real problem with addressing absence of toxicity versus presence. Any regulator will tell you, like, yeah, classify this because we have some toxicity. But if you talk to the same regulator and say, well, it's not doing anything, I'm not so sure that read across is kosher or not. At least that was my experience in the European environment. And toxicokinetics. Under REACH, for example, we don't make a mandate to generate that information, but sure as hell you need that for your justification. So there are some of the problems. Well, I've been all negative so far, but so, you know, yeah, read across acceptance, you know, we're pretty accepting of it as an approach. But at the end of the day, it's like you write a nice justification. Some of mine in the past for REACH have been 100 pages long. And I think if I can blind someone from reading all this stuff, maybe they'll just accept what I have to say. And, you know, they've obviously spent some time on this. It doesn't mean it's any good, but it's a subjective argument. You know, success in the eye of the beholder, if you like. And I think a challenge when I joined EPA, a couple of years ago now, you know, there are no objective means of read across. You know, I was having a conversation with someone at lunchtime, you know, where does the boundary between QSAR and read across start and finish? It's somewhere in that sort of continuum, but we don't really have any objective measures. There have been different approaches that have been looked at to try and look at the uncertainties both qualitatively and quantitatively. I want to draw your attention back to that P&G paper because they made a concerted effort to, you know, formulate this framework, identify what some of those uncertainties are, and come up with some kind of assessment factor of, you know, if I'm not sure about this, that, and the other, maybe I put another additional assessment factor and adjust the dose level, the dose descriptor accordingly. Molecular networks have been doing something quite similar. What we've done is slightly different. We're trying to be quantitative, but we're not interested necessarily in, you know, one case study after a time? To what extent can we say something on a more generalizable scale? So this is the work that we've done. We've published this already, so it's a bit outdated, but if I don't explain this, you won't get the tool. So, and that's kind of where I want to spend the rest of my time. So we have our mission. Our goal is to try and quantify uncertainty and get a handle on performance so we can say something for a decision context. You know, how confident are we with that prediction? Is it a good prediction? Is it not so good? But to establish that, we want to come up with a baseline performance. So if we don't take into account all those things that you think are important when you go through a read-across exercise, like metabolism, like toxicokinetics, like the number of analogues, if we put that to one side, how good or how bad can that read-across performance be for predicting different endpoints? And that was what we set out to do. And we've got an awful lot of work of how we go about refining that. And I'll talk a little bit about that towards the end. So our approach was really what we termed a local validity approach. Really what that is we come up with a category based on chemical structure or based on bioactivity assay hit calls from ToxCast. That forms our group. That forms our neighborhood, if you like, our nearest neighbors, or our category of source analogues. And we try and make a prediction for our target chemical, just looking at the similarity of all those neighbors and weight them based on their own activity to come up with a score. And that's what's reflected in that little graphic. And alongside is the algorithm, which can be a little confusing. They are not powers, they are subscripts, superscripts that impact the similarity score with respect to some context and what the activity is of that, and summing that across all the similarity indexes. Okay. If that was confusing, I hope this diagram kind of explains more the process. I should add, I forgot to add, sorry, I'm hopeless. We didn't come up with this like on our own. There's prior work. There's prior work by Larry Low et al. From Alex Stropsh's group. They came up with the CBRA, and really we're just sort of adapting it slightly for what we want to do. So our approach, we've got a lot of chemicals from ToxCast. We can generate a lot of chemical descriptor information. We've got the ToxCast hit calls. We have information from ToxRefDB. Can we define these local neighborhoods, these chemical groupings, and then make predictions and then see where we get to? What is our baseline performance? Can we assess that knowing that apical data already? And we looked at that in terms of if we've got chemical descriptors, if we've got a combination of those with the bioactivity descriptors or one or the other, and looked at kind of the predictions that we get and what sort of performance really sort of comes out from that. If you were interested in what ToxRefDB data we use, it was like 10 different study types aggregated together based on the toxicity effect that you get within ToxRefDB. So rather than giving a summary overview, yes, it's a developmental toxicant, yes or no, and we drill down and say, well, maybe we can say something about, we can predict liver effects within this type of study. And that's what this is sort of reflecting, the distribution of data for those different study types. In essence then, we didn't do any pre-selection of the inputs. We compared these different descriptors. We generated the predictions. We calculated the performance by constructing this area under the curve graph. And we found in some cases that bioactivity was a better predictor of these in vivo toxicity outcomes than chemical descriptors alone. But, we couldn't generalize to that extent. It really sort of depended on the chemical grouping and what the effect was that you're trying to predict. But we made some progress there. Why were we doing that? Well, I said at the beginning, it was really just to develop that baseline. We got that baseline, hopefully we can only improve from that, but at least we have a starting point to go forward. And we've been doing some more recent work in terms of trying to evolve that approach to factor in some of these other considerations. So if you ever read anything that in the guidance or the other papers, we always talk about the importance of, properties that will tell you something about the likelihood of something to be bioavailable, to what extent, something about toxicokinetic properties, reactivity, metabolism, all those sorts of important things that you would use to assess a source analog and judge it to be suitable for a read-across prediction. Those are the aspects that we're trying to front load in terms of refining that initial neighborhood that sort of gets identified from a search. And the one that we're focusing on at the moment is physicochemical similarity and looking at features or phys-chem properties and to what extent that they can refine those neighborhoods, and are we getting better predictions for that. But I've got some very tentative results and I didn't want to share them at this meeting just yet while we're still trying to interpret them. Moving on. So if that's the approach, we think we're onto something. We want to integrate it and test it out and get some feedback and see how well it's working. You know, is it a useful thing to be doing? So our intent, and you've seen a lot from Chris's talk this morning on the cont'd dashboard, our intent is to integrate what we've done in that dashboard environment. What we have now and what I'm showing you some screenshots is really what we have in a beta development server in terms of where that implementation would be. For those that were at SOT, we had a prototype that was standalone. What our efforts have been in the last few months is to what extent we can integrate that into a different environment so we have a more seamless dashboard rather than, hey, we have a tool, but you have to go to this web address. Why not have it integrated? Because we want to use a lot of the components that have already been developed as part of that dashboard. So the dashboard you've seen, I'm not going to focus on there, but you'll notice, and I hope you noticed from Chris's presentation, there are these little tabs across the bottom in terms of, you know, are we interested in chemical properties or toxicity data or expo data, exposure data, God, I can't get my words out, or synonyms or so on and so forth. So our integration has been that we've integrated GenRA, this is our approach, the generalized read-across approach, as another tab within that environment. It only appears as the first tab in the development server, but I could be bold and say, well, I think it's the most important one, so it should be first, and screw chemical properties as being up there. The thing going back to my workflow is, you know, I said some of these tools cover different aspects, so we're making a concerted effort to try and address many of these different steps. And that's why I've gone back to the workflow again to say, you know, I think we've covered many of these, or at least we've made inroads to address some of those. So we're very mindful of that workflow. And that's really driven the way in which this interface is looking like, because, you know, I'm no programmer. Those that know me know I know no programming, but I know what I want to see in terms of how I would look at it from an end user perspective. And, you know, maybe my perspective isn't, you know, is clearly not the only one. So we want to get some feedback in terms of how we should evolve it. So what we have is a grid infrastructure. When you have something in one window, it updates in the other windows. If you like the Windows Surface tool, which I happen to, this is a bit like that. If you don't, then, yeah. Anyway, so first window is really sort of looking at identifying your analogs based on some context of similarity. And I said that we looked at sort of these biochemical descriptors, these chemical descriptors, or a combination. So there's a little drop-down menu, and I hope you can see that in the first window where you can change that. So by default, we have one type of chemical descriptor. We can search for source analogs on the basis of that. You get this sort of nice radial plot that updates. If you touch on any of the chemicals that are the source analogs, your target's in the middle, then you'll pop up and you'll see, you know, what was the similarity index relative to that target. In the second window, you have what I would oh crap, I'll be quick, I'm out of time. In the second window, you have like your summary of like how much data do we know about our chemicals, not just for our target, but for our analogs too. And that helps initiate the next step in terms of looking at, you know, what's the coverage, not just in terms of your chemicals, how much data do we have, but how does it cover across these different study effects, and how, therefore, you know, we're getting a notion of what our data matrix might look like, but how realistic it might be to be able to make a read-across prediction based on, do my analogues actually have a lot of data? And that was a clear consideration in that first window in terms of being able to filter based on available in vivo data. So I only have 2 more slides, honest. Analog evaluation in this data matrix view enables you to start assessing the validity of those analogs on a very rudimentary level, but in terms of addressing that aspect, I hope you noticed in the uncertainty slide, in terms of looking at consistency and concordance across potency across those analogs, and the way in which this data matrix is faced, I hope that kind of starts to address that sort of concern in terms of being able to look across those analogs. What does my data profile actually look like? When you run a prediction, then you get a result. This updates the first column, which is your target and the predictions, and the scaling of that is reflective of how much confidence you have in the prediction. So it looks a little washed out. That kind of is reflective of how confident we are in a particular prediction. And you can export some of that information out into Excel. So I had one other slide that was just, if I went back to my table of these different tools, I've kind of updated that with where I think our tool is going, even though it's not out there yet. It's a beta for internal testing, but it will get out there, I hope. And it tries to address a number of these other things. So there's a ton more to do. There's many challenges in read across. I've only highlighted a few. I hope I've helped debunk or clarify this minefield of read across in terms of the tools and the frameworks. I think the uncertainties, like the real key aspect to address in read across prediction to result in its acceptance by agencies. And what I've tried to do too is sort of illustrate some of the work that we're doing in terms of trying to implement new approaches and implement them in tools that can be used by the scientific community. And on that note, don't yell at me. These are my acknowledgements. And I'll probably miss people, but yeah, sorry.